Going forward, we're recording this, but this is in the previous lecture video anyway, so. All right, so let's take a look at this. So let's change our program. We'll enter a number less than 5. So see if it's actually a number, and if it's not, we're going to exit right there. See if this number is less than 5. Some more sanity checking. So I want a number less than 5, so I'll say if the number is greater than or equal to 5, we'll print out an error message and we'll get out of here. So let's run this, enter a number less than 5. 4, that's perfectly fine. Negative 222 is perfectly fine. If I put in 5, it'll tell me it's greater than or equal to 5. So we can compare things, we can do inequality comparisons. The last piece of this you need is doing ands and ors. So here's how we do an and. So if bracket bracket some condition 1 double ampersand bracket bracket condition 2 so these statements are executed if condition 1 and condition 2 are both true. And use 2 vertical pipes for an or, 2 ampersands for an and. So is that all good? All right, so we've got statements, we've got conditionals, we need loops. Loops are pretty straightforward. There's a while loop. While space, bracket, bracket, space, any condition, space, bracket, bracket, do, list of statements for the body of the loop, and then the keyword done. So do is like an opening curly brace, and done is like a closing curly brace. So let's print the numbers from 1 to 10. So num is the number I'm going to print out. I'll initialize it to 1, and then I'll check to see if that's less than 10. And if it is, I'll echo the number, and then I'll set num equal to num plus 1. So the $paren says add 1 to num, store the result back in num. And I'm going to find I have one bug in this code.
Needs to be less than or equal to.
Has to be less than or equal to. But that's okay if you don't notice that, because if you don't fix that, you run it and it's like, oh, it only went up to 9, and then you'll find this. Yes?
So I noticed that it goes on the next line automatically without saying equal. Next line, 1, 2, 3.
Yeah. So how do you get it on one line? So echo dash n says do not output the trailing new line. So theoretically, if we do that, and if we put a space after each one, then it'll look a little better. And if we don't want everything to end up on one line, we can just put an empty echo at the very end. And there's probably what we had in mind. So there's manual pages, right, on every Linux system usually. And most of these things have pretty good documentation. And I didn't remember that dash n was how you did that. I thought it was. But you don't have to remember those things, right? Things you do every day that you'd like to memorize, well, you'll memorize them because you do them every day. And the things you don't memorize, there's manual pages. So manual pages, when you look at those, you use a Q to get it. Do you go over this in 121? Okay. So you use a Q to get out of this. This is one of the few things Control-C doesn't work. But it shows you a synopsis of the command, a description of it, and then a synopsis of how you use it, and then it'll list all the options and arguments and so on. Spacebar takes you down to the next page. And as you can see, Echo does a whole lot more than what we've been doing with it so far. Say again? And it tells you who wrote it, Brian Fox and Chet Ramey. And then Q gets you out. And if you can't remember what the echo command is, but you knew it was something that echoed your input, right, you can do a keyword search, man-k echo, and it'll show you everything that it mentions an echo somewhere in the synopsis. So if you can't remember how to compile, you can say man-k compile, looking for the keyword compile, and there's all the stuff that's related to compilation, and there's GCC as one of the options. So lots of help available online or in the system. All right, other questions? So let's look at PA1. So programming assignment 1, so this is the stick picking game that we've been working with this week. So you're going to write a shell script. It's going to be named stick. It's got to be named stick, lowercase letters, 5 of them, spell the word stick. Part of what we're doing in this course is we're getting practice at following program specifications. Okay, so you could call your program PA1, and when I loaded on the system, I'm going to know that it's called PA1, and I can type PA1 to execute it. But I want you to call it stick, right? Not because I can't run it if you call it something else, but I just want you to get into the practice of like following a specification. Okay? If you call it, stick with an uppercase S or PA1, I'm not going to take off points, okay? But I'll put a comment in the feedback section and ask you to note what it should have been called. So you call this program stick. When you want to execute it, you just type the name stick and hit enter, right? And here's what the program should do. First, it should print out a greeting to the user, okay? And this can be whatever you want, but basically, don't just start off saying, how many sticks? Because somebody who doesn't know what this program's doing doesn't know what's going on. So 1 or 2 sentences, right? Hello, this is my game. We're going to play a stick picking game. Whoever picks the last stick wins. How many sticks do you want to play with? So ask the user how many sticks. And then make sure that they type in an integer bigger than or equal to 10. So if they typed in a number that's too small, if they typed in something that wasn't a number, tell them, no, you've got to pick an integer bigger than or equal to 10. Ask them how many sticks again. And do that forever until they type in a valid response. Okay, then ask them who wants to go first. And they need to type either the letter C for the computer or the letter U for the user. If they type in anything else, remind them what the options are, go back, ask again. Do that forever until they give you the correct instructions. Okay, once you know how many sticks and you know who's going first, you start to play the game. So ask them how many sticks they want to remove if it's their turn. If it's your turn, the computer's turn, use your algorithm sticks mod 4 to figure out how many sticks to take. So if it's the user's turn, ask them how many sticks to remove. They type in a number, you subtract that off, and you go on. If it's your move, decide how many sticks you're taking, and then say, okay, the computer is taking 3 sticks. And then it's the computer's turn, the user's turn, how many sticks do you want to take? And this goes on until you're down to 0 sticks, at which point you say either you won or I won. Right, announce who the winner is. Okay, I also would like you to show a graphic of the number of sticks after each move. So if there's 5 sticks left, I'd like you to print out the following. 1, 2, 3, 4, 5. And then in parentheses, the number of sticks. You can make it fancy if you want. You can put it in groups of 5 or something like that. But all I require is a picture of that many vertical bars followed by the number in parentheses. All right, once the game is playing, illegal moves get treated differently. If the user does not type a valid integer or they type something other than 1, 2, or 3, tell them that's not a valid response. You've got one more try. Okay? If they type in something invalid a second time, they forfeited the game. The game's over. The computer wins. And you can tell them that and then just exit. But if they type an illegal entry, you say that's not valid, try again. They type in a correct entry. Okay, next time they got 2 shots at it again. So a few moves later, they type in an invalid number. You give them a warning. That's not valid. Make sure it's a number between 1, 2, and 3. If they put in a good number, you can keep playing. Okay, but if they put in an invalid number 2 times in a row, they forfeited, they lose, computer wins, goodbye. Is that clear? So that's different from the beginning where you let them try again and again and again to get the entry valid. So just 2 different types of loops you're going to have to think about coding up. All right, the algorithm we worked through already and talked about. Basically, you want to take n mod 4 sticks if it's your turn, if that's possible. If n mod 4 is 0, just take 1 stick. Okay, so that's the 1-sentence algorithm. All right, so requirements. It's got to be a bash script. Okay, this is not a C program. But programming assignment 2 will be the same thing, but it will be a C program. Okay, so doing it in bash first, and then we're going to do it in C for the next assignment. Make backups along the way while you're doing this. Okay, make sure you don't just have 1 copy of your program. Because when you edit a program, when you try to upload a program, things can go wrong. Okay, keep a copy somewhere. One sort of all right, so there's my big long program PA1. Here's an easy suggestion. Make a directory called backup. And every now and then just copy PA1 into backup. Now you edit PA1 and you do some other stuff, right? And you're feeling pretty good about it, make another copy into backup. Backup will always have the latest copy that you've put in there.
Can I date stamp it if I want to keep?
Yeah, absolutely.
How do you make it so it doesn't just keep overwriting it?
So you could copy PA1 backup / PA1.version4.
Okay.
That's a kind of manually intensive way, but that'll work. And then I can do version 5, and now I can look in backup, and it's got all my copies. But we'll learn enough Unix commands pretty soon to see ways that you can automate this. So I have a backup command. I can just say backup, and it creates a subdirectory with a timestamp and copies everything in there. We'll see ways to do that soon. All right, so make backups. Don't lose your work. All right. Make sure that your script is commented. So in the very beginning, I want to see what I'm going to call a comment block, okay, which should include your name, the course number, the date, the assignment number, and then a brief. It can be just a few sentences, but in your own words, a description of what the script does. Okay. Again, think of yourself a year from now. You're at a university, you're trying to come back and review what you were doing here at Clark. Here's something called PA1. I don't know what that is, or stick. Block of comments that basically refresh your memory. So, stick picking game, we're going to pick sticks, blah, 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 right? And then comments throughout your script. Anytime that you're doing anything that's not totally, completely, 100% obvious, put a comment in. If you have something that says echo hello, you probably don't need a comment. All right, what would your comment be? Say hello. It's probably not going to be really useful, but if parentheses $paren n%4 -EQ0, right? You're not going to know what that means, right? You're not going to know why you put that statement there. Throw in a comment. See if number of sticks left is a multiple of 4, right? And then you don't have to reverse engineer the actual code. So lots of good commenting, and another goal of this quarter is to let you develop a commenting style, and more generally a coding style, right, that works for you and makes sense for you and is easy for you to read. So commenting should be a part of that.
So, can you just repeat what needs to be in the comment block?
Yeah, it's right in here. So
Oh, it's in there, okay.
your name, course, the date, the assignment number, and a synopsis in your own words what the script does. That's coming up right next. So, so this next bit has to do with submitting your assignment. So, let me pop over here. So you write your program, and it's sitting on the Linux server, and you need to submit it to Canvas for grading when everything is done. So here's PA1. And there's a button that says Submit Assignment. And when you click on that, you can go down to Choose File and browse your directory and find your stick program and submit that. So there's some things that have to happen to let you do that. So who's used zip files before? Most people have encountered zip files. Here's the idea. You have a batch of files in a directory, maybe in multiple directories. It can be convenient sometimes to take these and collect them all into one file. So in Windows, usually we use something called zip, or zip7, or whatever your favorite tool is. In Linux, we use a command called tar. And there's only 3 tar commands you need to know, but you gotta use these exactly the right way. If you use them the wrong way, there's a good chance that they will destroy your program. Good backups, right, are important. So here's the first version of tar. Tar space CVF space archive name space, and then a list of files that you want to put into your archive. And this creates an archive. Containing these files. And the name of the archive is whatever this first argument was after CVF.
What's that say? Archive name?
Archive name.
When you, for the files, so they need to be separated by a comma. or
Separated by spaces.
spaces.
Yeah. Pretty much any time that we list multiple files in Unix, that's going to be the answer. Unix is like spaces. So let's see an example of this. All right, so let's get rid of this. So I got 4 files in here: file 1, file 2, main file, and PA1. So for PA1, you've got one file called stick, and that's the only thing you're going to submit. But you may, in future assignments, have submissions that have more than one file, and that's where this is going to make more sense. But let's just stick with stick. So here's my script that I want to submit. So tar CVF. I'm going to call my archive stick.tar. And then I'm going to list the files I want to put in there. Stick. And it tells me stick. It's telling me that it added this file stick to the archive. And if I do an ls now, I've got 2 files in my directory. This is my original script. This is the tar file, the archive. This is the thing I'm going to submit to Canvas. Okay, it won't let you submit just a plain file. All right. The second command you need to know is tar tvf. Say what?
Create an archive something.
Create an archive containing these files. So tar tvf archive name, that shows you the contents of the archive. So I've got a tar file over here called stick.tar. If I say tar tvf stick.tar, it shows me it contains one file called stick.
And should we name the archive .tar?
That's sort of conventional, and if it's not named .tar, Canvas won't upload it. So, but in general, it could be anything that you want. But don't call it stick, because that's the name of your program, and it'll obliterate it. That happens more than you would believe.
And it basically shows what's in the tar file.
Shows what's in it. So the T says table of contents.
Okay.
So let's say I create an archive stick.tar that contains 4 files. file 1, 2, 3, and stick. When I say tar CVF, it'll show me the names of the 4 files that it's adding. And now if I say tar TVF, it shows me all 4 files. And this is not a bad backup approach, because you can take your entire directory with all the files in it and crunch it into this single file, this .tar file, and now you got one file to deal with that contains all your stuff. So you can throw that into another directory and so on. And then the last command is xvf. And xvs says copy the files from the archive into the current directory. So X is for extract. So C is create, T is table of contents, X is extract. So suppose all I have is this stick.tar. That's the only thing in my directory. I can say tar extract verify file stick.tar, and now I've got my files sitting in here. They're still in the archive. It just copies them out. Make sense? So the way that people get into trouble is they say tar CVF and they start listing all of their files and they forget to put in the archive name. And tar doesn't know that's what happened, so whatever the first file is that you list, that becomes the archive. And if that had code in it, that code is gone. And it doesn't tell you that this happened because it doesn't know that that's a problem. So now you submit your archive and it doesn't exist. And so you execute the correct command, but you've munged that first file. And you submit your tar file and I extract it and I start trying to execute it, and there's a file that's not a bash script or a C program, it's actually a tar file. And if you don't have a dated backup, then it's hard to sort of recover from that. So be really careful with these, make backups before you start messing around with tar. All right, so use the tar command, right? And I gave it to you verbatim up there to make an archive stick.tar, upload stick.tar to Canvas after you've uploaded your code. It's a good idea to download from Canvas, push it onto the Linux server, use the tar xvf to get your original script and retest it. If you can do that, that's what I'm going to do when I grade. Okay, I'm going to take your tar file, I'm going to push it onto the server, I'm going to say tar xvf, stick.tar, and then I'm going to say stick. So go through those same steps yourself and make sure it does what you want it to do, which is run your program.
Where can you find the tar file once you create it on the Linux server?
So it will be in whatever directory you ask it for. So if you just say stick.tar, this is going to create stick.tar in your current directory. So the other part of that question is, how do you get it from there onto your own machine so you can upload it to Canvas, right? Because we can't upload to Canvas from the Linux server. So you've got a few options. Let's get out of here. And let's go down to this how-to guide. So transferring files between Linux and your own system. So if you're on Windows, I recommend getting this program WinSCP. And when you run that, you log in with your usual login information for the server. And now you get a pair of side-by-side windows, and it's like an old file manager. One side is your Windows system, the other side is your Linux account. And you can just drag and drop files back and forth. It's really easy. Okay, so that's one way to transfer files if you're on Linux, on Windows. If you're on Linux or OS X, the way I recommend is to use this SFTP command. So from your Linux machine or your Mac, you would say SFTP, username at linuxengrcs.com, log in, and now you can say get and put to transfer files back and forth. So if I say get file.c, it'll copy file.c onto my current directory under Linux. And if I say put, it'll read something from my Linux system and push it over to the server. And experiment with that before the deadline, and keep backups. Yeah, please practice on junk files and learn how to use these programs' commands. Don't wait until you have a finished program. It's easy to accidentally delete your files. So I could say that like the rest of the quarter, but I won't. All right. Good enough? All right, so let me mention one more thing. This is a bit of an issue of terminology. So ODP 403, for example, requires us to enter a number while the program is running. So we start the script by saying, script or ODP 403 or whatever we call it, and while it's executing, it stops and it waits for us to type in a number. Okay, this is what we've been doing in most of our programs so far. This is something I'm going to call a program input. Okay, it's something that you type into your program while it's executing. There's another way that we can give information to a program, and this is something I'm going to call a command line argument. And a command line argument, if I have a script called main, and I can say something like main space 25, and my program is going to do something with this number, right? This is what I would call a command line argument. It's different from saying main enter, my program's running, and then I type in a 25. That's a program input, okay? When you type in some input to your program on the same line as when you're specifying which program you want to run, right? Main space and some argument, that's a command line argument. And this is just a terminology, but we're going to see programs where I'm asking you to specify program inputs. We're going to see programs where I want command line arguments. And I'll remind you of what those mean each time that we encounter them, but I just want to sort of introduce it here for a first perusal. Command line arguments are not something that you type in once the program's already started. They're something you specify in the very beginning. Okay? Everything else is a program input. That's stuff you type in while the program's running. So just terminology. All right, so I started the recording a few minutes late, but everything we did in the beginning is in the earlier version, the earlier sections recording also. And then the rest of this I'll post right now. All right, I will see you next time.